Cool. So everybody should have got an email. I believe it should have come from Tovio regarding the week 1 survey. So we put together a little survey. We want everybody to complete this. Tovio posted the link to it above. It's also should be in your email. And when I say above, it's immediately above my my message in the main channel thread. There's the link to it again in the actual thread this time. Okay. Cool. So everybody go through that at some point. You don't have to do it right now, maybe after class, because we're going to get started with everything. But if everybody could get that in, that would be helpful for us. And I do want to just remind folks about study halls. I know a number of you have been showing up pretty regularly. But yeah, if you haven't been showing up to study halls, you know, it's not required by any means, but it is it's just a resource for you to access if you want it. So I run study halls every Monday, Wednesday, and Friday at 4 p.m. to 5:30 p.m. Mountain Time. So I always get fog, or that'd be 3 p.m. to 4:30 p.m. Pacific, and 6 to 7:30 Eastern. If you're Central, you can figure it out from there. Okay, cool. So yeah, that's just a stream that I do on YouTube. So if you subscribe to our YouTube channel and do the little bell icon, you'll get a notification for that. Or you can just pop into the study hall channel on Slack. You all should be invited and members of that study hall channel, and I will post the link to that there every Monday, Wednesday, and Friday. Also, as a note, you're welcome to reach out for mentoring, like one-on-one mentoring with Tovio or I, and we also have several other members of the team, Lance Bartow, Devin Dijon, and Remy Arata, who are available for various mentoring sessions as well. So you're welcome to reach out to us if you need help. We've also got Basic Prep, which is a good place for, you know, to get peer support. If you have a question about something from Learn, you can post your question in there. And you know, you can help other people if you see a question that you can answer. You know, just monitor it, and you can maybe help somebody out, or you can get a question answered there. Cool. So let's jump into the thing. Where is it? That's it. Okay, good. Is that okay? Oops. Good. So I do want to do an overview again, just a quick overview. I think this helps kind of give an idea about how everything fits together. I know, like, when you're acquiring new knowledge, or at least for me, it's an important thing to be able to know, like, okay, well, I learned all these things. You know, what does that mean? How do they relate to each other, right? So I kind of break things with a programming language. I kind of break things into 4 categories. We've got, actually, we'll make this a little breakout. So I did this once with 4 categories, and I did it once with 5 categories, and I think at least the 4 category version is the thing to do. But you could you can include that 5th category if you wanted. But go ahead and put it in Slack. Does anybody remember what the sort of categories that I broke broke the language into before. Go ahead and put it in Slack if you remember. Data types and control flow was 2 of them. We can crowdsource this. I just want you all to like give it a think for a minute. I know I've only done it once, so I don't mean it to be too dirty of a trick, but yeah, do your best. Get in what you can. If you remember one of the categories, feel free to put it in there. I did have data types. What do you mean crowdsource? I mean, yeah, you know, appeal to the group memory. You know, if maybe one person remembers a couple of them, somebody else remembers the other ones. So, yep, abstractions. Yep. So data types. We've got data types, control flow. Abstraction. I'll give you the last one. I'll be nice. Let's call this iteration. I think last time I called it loops by accident. In a practical sense, like the iterators that we're going to focus on are loops. So, but iteration, or you could think about this as repetition. Repetition is just being able to dynamically repeat something, you know, a number of times that's equal to something that's determined in the program, maybe. Not necessarily something that you hard code in. You imagined iteration as part of control flow. That's a good observation. I certainly imagined it that way when I was first learning. For months, somebody was like, "Oh, you got to know control flow," and I'm like, "Okay, so that's like ifs and loops together." It certainly sounds like it would be that way, but let me clarify this. Control flow only means only refers to if, elif, and else. That's it. I don't know why they didn't, like, why this isn't like canonically referred to as like conditional logic or like dynamic logic or something like that. That would actually like be a term that would describe that. But control flow, I guess, sounded cooler, and it makes it sound like you're controlling something that's flowing, I guess, which, I don't know, seems neat. But it actually explicitly does not refer to iteration, which is kind of a weird thing. Yeah, I wish it did. It would be kind of cool if there was a term for the synergy of, you know, using both of them together. But yeah, that's the way it is. So good that you observed that, because that's an important thing to clarify. What do I mean dynamically repeat? Okay, so imagine here's something. Imagine I wanted to. We're going to talk about lists today, so I will quickly introduce a list, and then we'll talk about it later. So I've got this list with 3 numbers in it, 4, 8, and 6. And let's say I want to add these numbers together. I could say list sum equals the first element in the list, which will be list sub 0. And then I could say list sum equals list sum plus the second element of the list plus the third element of the list. Third element of the list. I know I'm using 0 for first, 1 for second, and 2 for third. We'll get into that in a second here, but you know, if that doesn't make sense, just bear with me. That's mostly what we're going to talk about today, is lists. So it's a good start. So I've got this code, and I'm repeating this process, right? I'm starting off with this. You know, I could do something like list sum. I'll just start it at 0 first, and then I could repeat this sum. Oops. Sum like this. Right, so these 3 lines of code are repeated. I'm just following a theme, and I'm just changing one aspect of it each time, and I'm changing it in a predictable way, right? This number is 0, 1, 2, and if there was more, then 3, 4, 5, 6, 7, right? So we're just counting up with that number. So this line is being repeated, and the difference between each line is predictable in a very straightforward way. So this is great if I have a list of 3 things, but what if I don't know how many things, like, before? So while I'm coding this, I have the opportunity to know how many elements there are in my list. There's 3 elements, right? But while the programming is running, it's likely that this list is being built and generated from other sources, and I don't know how long it's going to be. What if it's some unknown number of elements? Well, then I've got to go, change my code just because the list changed size, right? So I have to know the size of this list before I can run the code, but it's likely that I can't know the size of the list until I run the code, So it's sort of a catch-22. This list is determined by the code running, and, the code has to know how big the list is. So it's useful to just say, well, for any size of list, I want to be able to do this kind of similar logic. So what I could do is, and we're going to talk about this as well, I could write a for loop for I in range. We'll get into this, I promise. Range len list. Len will give me the length of the list back. We'll tab that in, and then there I go. So range generates a number between 0, starting at 0 in this case, and up to but not including the length of this number, the length of this list. And it assigns each of those numbers to I. And then we do this process. And this is that process, just kind of generalized. And this will work for any length of list. I don't have to know the length of my list now in order to build the sum this way. So that makes it easy. So I'll delete these for now. Don't try to think about that too hard right now. I promise we're going to go, that's what we're going through today. We're going to go through it slow. So, don't worry about that. We will get to it. Question, by dynamic, did you mean at runtime, or please clarify? I guess you could think about it like that. Yeah, I mean, we need to write code that is able to determine things at runtime, right? So are you saying dynamic for any input length? Yeah, exactly. Yeah, it responds to the input length. Cool. I'm just kind of trying to give a quick skim here. I'm making sure I didn't miss any questions. I don't see. Okay, I'll leave it there for now. If you do have a question, just at me. If you have a question for me, feel free to just at Clark in front of it, and that'll help me see it. We'll move on for now. So this is our overview. These are our bulk categories again. So I'll just fill these out a little bit. I just showed you a for loop, and there's another kind of looping structure that is important to know. It kind of fills in some gaps that for loops aren't well suited for. That abstraction is a while loop. So we can use for loops for most tasks. For loops are generally pretty easy and straightforward to deal with, whereas while loops are, burden us a little bit more with managing them, but also can do some things that for loops aren't as well suited for. Control flow is limited to just if, elif, else, right? This is a bit of a big topic in terms of, well, it's one of those things where it's made out of simple things. It's these three keywords, and then we're checking conditions. A condition is any expression that evaluates to true or false. That's it, right? So I mean, these are the basic rules of control flow, but yeah, I mean, I think learning to combine those and kind of learning which expressions and give Booleans back, and there's some kind of creative things that you can do with that take a little just practice, but it's not so bad. Abstractions are going to be variables and functions. And then data types, like I said, I tried to emphasize this before. Learning these three is about kind of learning, the first time you learn them, it's about, okay, why do I need these? Why are each of these important? You might ask, like, well, why would Clark break out each of these topics into their own topic? Like, why not put like object-oriented programming or something, right? Like, why is that not a category in here, right? So that would kind of fit in here in a different way, but and I could definitely make more topics that cover everything about a language or computer science, but like I said, this is a basic schema to get you like off the ground and running, and when you want to go learn other features, this is the foundation that you'll need to learn those, right? So the reason I choose these is that this is sort of at the core of your problem solving tool set, right? You want to be able to write code that can determine, which parts of it can run at runtime. So that's your control flow. You want to be able to repeat things dynamically and determine those repetition patterns at runtime. That's iteration. You want to be able to write code once and reuse it multiple times, and variables and functions will help you with that. And then learning these, once you kind of get the idea, oh, this is how they all fit together, it's a matter of getting good at the syntax and implementing the exact details of these. And then the rest of the work, and really in my experience, most of the time spent for me learning a language is in this first category in data types, right? Int, float, bool. Let me do bool down here. Bool. We talked about strings, none. Today we're going to talk about lists. And the reason is, each type has its own domains where it can be applied. Some, with ints and floats, there's a lot of overlap. So sometimes there's overlap. Sometimes, you can cast one type to another, but not the other way around, right? So casting between types is something that you want to know about. Which types can you cast to what other types? You don't have to have a comprehensive knowledge about that, but you want to have a sense of it. You want to have a sense of casting in general, how converting from one type to another works, when it's required and when it's not. And then basically the work in here looks like learning about operations and functions that can be applied to each of these types, right? So for example, and this won't be comprehensive to ints and floats, but by example, some operators that we can apply to ints and floats are plus, minus, times, divide, mod, exponentiation. Right, so those are some operators that we can apply to floating point numbers, or integers and floating point numbers, right? Then knowing it can both be positive or negative, and there's some times where you'll have an integer in one of these operations, and you'll have a float in the output. And sometimes that matters, and sometimes it doesn't, right? So learning all those details is kind of where the rest of the work is. I feel like this ends up being, 70-80% of where your time gets spent ultimately. So just so you expect that. So yeah, again, hopefully that kind of breaks things down, shows you how everything relates together. Today, we're going to be covering lists and for loops. So today, you will now have sort of a piece from every category, and we'll be getting into lists, which are sort of different than the scalar types that we've talked about. The lists are not a scalar type, and we'll talk about what that means as well. Okay, cool. Looks like I got a couple questions here. Could I potentially give a title for those 4 types? Like, are there 4 types of what for my notes? Oh, 4 types. Unfortunately, I'm not sure what you're referring to. Apologies for that. Oh, scalars and collection. Okay. Define schema. So schema is the root of schematic. So it's a schematic is it's a generalized form of, I think about it as in context with a circuit, an electronic circuit. But basically it's a generalized plan, a non-specific plan. It can have specificity in it, but it's meant to describe the form of something rather than the actual thing, right? So I guess I would describe it as a description of something's form, kind of. Side note, your OBS window, why? My OBS window is in the screen? Is it in the screen now? Okay. Zoom is so wonderfully designed, it's beyond my comprehension on how it works. So I guess that's what's happening. Anyways, I'm being sarcastic. Cool. So I put these out of order, dang it. It's kind of scrambling to get everything put together. Okay. I had some breakouts in here. Actually, I'll find the breakouts in there over the break, and we'll come back to those. Do them as kind of some review. I want to get right into lists. Oh, OBS is back. Oh my gosh. Why? It's supposed to only be capturing. Let me just try to restart my screen share here. That is so weird. Okay, is OBS blocking the slide still? Okay. I do not understand why Zoom is doing this. It's not supposed to be doing that. Okay, let me just kind of shake it around. Hopefully that'll clear it out. Okay. That should be better. Okay, cool. Thanks for letting me know about that. I don't know, that's a weird thing. All right, lists. Let's get into lists. So describing a list. You saw me use a list as an example and just now. So you might have a bit of a sense of it. I just made a list of integers and accessed each one. So a list is a collection of arbitrary objects. Now, arbitrary just means an object of any type in this case. The type isn't constrained to, it isn't constrained by anything. So a list is a collection of arbitrary objects or are objects of arbitrary type. There are, let's see. So I think it's in Python. Python uses heterogeneous lists, which means that not only can we put in any type, but we can mix and match types as well. So the way we declare a list is with square brackets like this. And this will delimit the beginning and the end of the list. Okay. So this just denotes, where the list begins and where it ends, and then everything inside it is obviously the elements in the list. So to make an element, all I do is put in, something that evaluates to a data type. Something like that, right? So I can make a list of integers, right? So this is what's called a homogeneous list, where we have a list of only one data type. So you can do this, but Python doesn't enforce it. Python doesn't restrict you to only using one type. Although I think it's safe to say most often we will have a list, a homogeneous list anyways, right? But I can mix and match. So I could say 3.14, 87, hello, and I could have another list in there with 1, 2, 3, hi, like this. So I can mix and match whatever data types that I want to put in there. I can put anything in there and combine them to my heart's content, including other lists with other elements in them. Cool. So some other things about lists: they are ordered, which we'll kind of get into this, and they are ordered and mutable. They are ordered and mutable. So to be clear, I know I mentioned this, but to be clear, separating elements in a list is done with a comma, right? So Python knows that each element is separated in the list based on where the commas are, right? So you don't need the spaces after them like this, but it is convention to put them in this way. So let's look at ordering and mutability. So I'm going to make a variable. I'm going to call it LST. You might be tempted to call it LIST. This is the type specifier. There's a function called LIST, and it's related to lists, and we'll kind of get into using that. That's the function that we would use to cast something as a list. And there's certain things that we can cast the lists. If you'll recall, right, int has a function that we can use to cast things to integers, and list has a similar function called list. So you don't want to call something LIST. The convention is just to call it LST. So I'll just make a quick integer list. And So let's talk about if I print this off, and it probably won't come as any surprise. And you know what? Why don't I do this? Just to make it clear. 3, 4, 5, 6, 7. If I print this off, no big surprise that it comes out in the same order. Now, this is a feature that's guaranteed about lists. So the order in which elements go into lists is preserved. That might seem like it would be a given. Like, why would I even mention that? Of course they'd be preserved, right? Well, it makes sense to us because it sort of appeals to our spatial reasoning. If I have a shelf and I put things on the shelf from left to right, the objects on the shelf are going to stay in the order that I put them in. You know, they have a physical location that's not going to change because the universe forgot which order they went in, right? It doesn't work like that. And it's easy to impart that understanding on lists. And in this case, that understanding holds true. But the reason I'm pointing it out now is that there are other types where the order is not guaranteed. A data type having a collection data type, and there are other data types that are other kinds of collections. We'll be talking about dictionaries and sets as well. And those kind of go with, and tuples, and those will kind of go with lists. You'll see kind of similarities, but a collection in a computer does not have an order necessarily unless it's built to, right? So a list is built to have an order. It's built to retain this order. But other types won't have that order. So I'm more kind of making a big deal of it now because it'll come up later. You know, don't get it, totally fixed in your mind that all types will retain their order in the same way that lists will. Okay, so it's important to know that lists do have an order. They will retain that order. They are mutable. So mutable is related. It's the same root as mutate or mutation, to change, right? So lists are our first mutable type. So all the other types that we've looked at, all the other data types, int, float, bool, string, none. There's another one which is tuple, and we'll come back to that later. Tuples are kind of similar to lists except they're immutable. So all the types that we've talked about before this are immutable. They're the scalar types. So all the scalar types are immutable. What that means in practice is once we give them a value, they're fixed to that value. That's it, right? We don't change the value of an integer, right? Now, you might think, well, that's not right because, I have a variable, if I have 5 and then I have a equals 6, that this looks like you might describe this as changing the value of an integer. That's not how we think about this, and that's not, I would say, and it's a little bit subjective. It's a little bit of a, an established paradigm that, computer scientists kind of think about it this way, and you could think about it a different way, but the paradigm that we establish is the integer is not changing here. And it's important to know that the integer is not changing here. We didn't take 5 and change 5 to 6. What we did is we set a equal to the fixed value of 5, right? Now a is a variable, right? A equals 5 is a variable. And we could break this down. A variable has 2 parts. We could say the name part is the identifier, and then the data part is the data, right? So, or the value. So we have an identifier and we have the value. So the value, it's in this example, does not change. What does change is the identifier points to a different value, and we're allowed to do that arbitrarily in Python. So this is not a mutation of an integer. you could think about it as a mutation of a variable. So just because a data type is not mutable doesn't mean that the variable can't be reassigned in a way that makes it feel like it changed, right? So yeah, so lists have a bit of a different capacity built in. So we have the ability to change this value on the level of the value. Of course, we still have the ability to reassign the pointer arbitrarily in the same way we would with anything. That doesn't change. That ability to reassign the identifier and to point to a different value is still exactly the same as it is, but it's a different mechanism from being able to alter the value on the level of the value, right? Yeah. I feel like I've been kind of waiting to build up to this. I'm gonna backtrack for just a hot second here. I kind of waited to build up to this, and I didn't want to overload folks too much. I decided to skip talking about reassignment operators, but I think we're at this point, and I'm like, well, I really need to talk about these. Okay. So just a quick digression. We'll get right back into lists. We have we'll have a variable. We'll start it off with a value. This is an assignment. This is, in this case, an assignment and initialization. So initialization is what happens when something doesn't exist and then you initialize it. You make it exist. So initialization means I brought this into existence, right? I could say A equals 1, and this is an assignment, or we could, oops, sorry about that. We could say an assignment, or we could call it a reassignment, right? Since it's already initialized, it's no longer an initialization. We could call it an assignment or a reassignment. So there's some operators that will reassign the variable in kind of a dynamic way. So one thing I can do, I'm going to assume that A equals 1. Let's say I just want to add 1. Let's say I don't know what the value of A is. But whatever it is, dang it, sorry. Whatever it is, I want to add 1 to it. So I can say A equals A plus 1. Okay, so a variable that already exists, in other words, a variable that has a value that has already been initialized, can be reassigned like this. So it can consider its current value on the right hand side, right? So what this is saying is the new value of A is equal to its current value, which is 1, plus 1. So if I print A, I'm going to get 2. So this is such a common and central thing in a lot of the ways we commonly solve problems in programming languages. This is such a common thing to do that there's a short form version of this. So there's sort of a shortcut, and this is called this kind of shortcut is called syntactic sugar. And what that means is it's just some syntax that makes something a little, quote, sweeter, right? It makes it a little nicer to deal with, right? So this is not terribly clunky because it's just a really simple expression. But these kind of expressions can get much more complicated. So this kind of expression is just kind of makes that a little shorter, a little nicer. So if I want to add 1 to whatever the value of a is, I can do plus equals like this. And syntactic sugar just means that when Python sees this in the code, behind the scenes, the interpreter literally rearranges that line to look like this, right? So if we, what would it be in the yeah? If we looked into like how the interpreter was reading the code, we would see every time it encounters a line with this plus equals, it'll say, "Oh, I know what this means. This just means to do this." Like that. Just move that a plus over to the other side and just treat it as a reassignment like that. So because of that, we can do this with any operation. We could do minus equals, we can do times equals, we can do divide equals, floor divide equals, we could do mod equals. It's really common to see plus and minus and occasionally times equals. The other ones I have seen show up in various algorithms, but it's not as common. So a little note on reassignment there. Okay, now I wanted to cover that because it'll kind of be important when we start getting into accumulation. We'll be using those operators a lot. Okay, back to lists. Okay. Comment, the list indices maintain an order. Yes. Okay. So let's talk about the range function. Range is a function. It's also, you could also think about it like kind of its own data type. It's kind of similar to a list in a way. I'm not going to put it on here because we actually don't really consider it its own type as much. But it gives us something back that is, we can think about it like a list, but it's also important to note it isn't actually a list. But there's situations where it behaves similarly. We can think about it as a collection of numbers. So the range function helps us. Oh, looks like somebody came off mute. If everybody would check and make sure that they're muted real quick. Cool. Okay. Okay, cool. All right, sorry about that. So the range function helps us create a list of integers within a range. So let's look at this. Let's look at the range function. So if I say, we'll call it my range. Oops. We'll take in range, and let's just do range 10. So if I print my range, you can see we get range 0 to 10. So this doesn't really give us as visually satisfying as of a representation as a list, but we can use the list function, list function, to convert it to cast this range into a list. Okay, so I've got a little breakout idea here. Let's do this. let's say okay. Cool. So here I make a range, save it into a variable, and then I print out the range and I cast it as a list so I can print it out as a list. If I print the value of my range here on line 50, so my question, I'll pose a question, will this line print A or B, right? So will it print range 0 to 10, or will it print the list? Go ahead and put it in Slack, A or B. Interesting. Cool. We've got some disagreement. You might be wondering, because I haven't really explained this too much, but you know, so I realize that this might be a little bit of an unfair question, but what I wanted, the reason I'm asking this is I want you to notice what your intuition tells you, and you might already just know this behavior. A couple of you I know, you know, just know this behavior. But if you don't know this behavior, it's important to just take note of what your intuition tells you. And take note that you have an intuition, that you have, you know, a sense about what this does. Okay. So what if you answered A or B, what would be your explanation? What would be your justification? What am I trying to ask here? For anybody who feels like it, who gave an answer, feel free to justify your thinking and why you gave that answer. The first one, wait, the first will print B, the second prints A. You get B, you have to cast to a list. To get B, you have to cast to a list. Okay. My range stores a range object. Oh, we'll print A. Okay. It doesn't range, somebody's asking, doesn't range output a list? No, so range actually outputs a type called range. It's sort of, I'm not including it here in like the list of major types. Let's think about it as kind of a minor type. It's not, we don't even really think about it as a data type in the way that we think of the other ones. Because its use case is pretty narrow. We tend to use it in a very particular circumstance. And then when we use it outside of that, we'll just cast it as a list when we need it to be a list. So I kind of think about it as sort of a subcategory of lists. Okay, cool. So I just wanted to get some people's thoughts down in Slack. Feel free to put, you know, don't mean to cut anybody off. If you want to put in your thoughts, feel free to share that. And I would encourage you all to like go through and like read these and, you know, see how other people are thinking about this, and you know, try to get some other perspectives, you know, even if you do know the behavior here. So okay, so to be clear, to recap, I ran this code initially with my range. We got range, And then I ran it again, casting it to a list. We got a list. And then I asked the question, so if I run these together, if I cast my range as a list, and then I print my range, what's the result, A or B? So that's what we're asking here, and let's find out. So, let's do this. List, and we'll do this. X and Y. So we'll mark these so we know which one is which. Okay, so X gives us the list because I'm casting it as a list, and then Y is the range, right? Y gives us range 0 to 10 again. So what I wanted to do is sort of have you notice that you have, like, some of you may have an expectation that casting like this will cause a change to the input. There is no function built into Python that will do that. You can write functions that do things like that, but you shouldn't, and we'll get kind of more into that as we get more advanced with lists. But for now, it's safe to assume that functions do not mutate their inputs. So when we pass an argument to a function, it's capable of, but not allowed to. By convention, it's never allowed to mutate its inputs. So we can just assume that a function will never mutate its input. And what I mean by that is when we pass in my range, if I use my range again, having passed it into a list, into a function, doesn't change the value of my range. So it doesn't change it to a list. All it does is say all line 49, the line marked with X, all this does is say, like, hey, give me a version of range as a list. If I converted range to a list, what would that look like? If I wanted to capture that value in a list, I could do this, and I could say my list. Okay. So back to that idea of a function or an operation changing a value. So that kind of behavior does exist in parts of Python, and it's called mutation. And so let's look at a mutable operation. So this is going to be our first mutable operation. And remember, so I'm not talking about, like creating a value and then reassigning it to something else, right? So no mutation was performed here. And you could say that we mutated. Some languages would think about this as mutating the. Oh, come on. I hit the wrong shortcut key. I'm sorry. Dang it. Apologies. What a pain. Okay. Some languages would think about this as mutating the identifier, but we're not mutating the value. So let's look at something that does mutate a value. We'll say list equals, we'll start with an empty list. This is a totally valid list. If I print list, we're going to get an empty list. No big surprise there. So lists have, actually every data type has a number of what we call methods. And a method is like a function that is built into a data type. So it's like a feature that's like a function that's built into a data type. And the way we access some data types methods is we'll do the type. This is, in this case, this is a list dot append. Dot method name. In this case, the method I want to access is called append. And we will pass in so append. So this, you can see append kind of looks like a function, but it only exists in the context of lists. And append, as you may be able to glean, will add in an element. It will append an element into our list here. So the element that we want to append is just going to go inside the parentheses. So let's say I want to append 5. So this code reads initialize an empty list, print it off, and that's just going to show us the empty list. Then append to the list, and then print off the list again to see if it changed, and it does, right? If I append multiple things, it appends multiple times, it changes the list. So notice this is not a reassignment. I didn't say list equals list with 5 in it, right? So I didn't. This example on line 62 creates a list that contains the value 5 and reassigns the identifier LST to that list with 5 in it, right? Line 61 just says mutate the value of that list by adding 5 in it, right? So this list changes the identifier, or excuse me, this line 62 changes the identifier, line 61 changes the value. And when we have a data type that has methods that are built in that are capable of changing the value, let me say that again. When a data type has methods that are capable of changing its value, we call that a mutable data type because we can mutate it. That's what that means. Somebody's asking if I can give a example of range providing indices. Yes, I haven't talked about indices for lists yet, but that's basically what we're going to get into right now. Cool. So this is an example of mutation. Yeah. So let's talk about indexing. So I'll have a list, and we'll just do, let's just do 55, 44, and 77. Oops, forgot my square brackets. There we go. So it's common once I have a list to want to be able to access different elements inside of it. I'm just trying to think of some random elements here. And the reason I'm doing these doubled numbers is to make it clear which are elements and which are indices. You'll see why in a second. So I've got a list with 1, 2, 3, 4, 5, 6, 7, 8 elements in it. We would call each of these an element in the list. Each of these numbers. So it's common to want to be able to access one of these numbers. And to do that, lists have a mechanism built in called an index, right? So each of these numbers is assigned an index based on its position from the left to the right, right? So 55 is on the left, and then 44, 77, etc., right? So the first index is assigned the number 0, okay? So the first index is assigned 0, the second index is assigned 1, the third index is assigned 2, etc. So index 0, index 1, index 2, index 3, 4, 5, 6, 7. So this list has indices from 0 to 7. But notice it has 8 elements. So I would say, the way we would say this is its length is 8 and it has indices 0 through 7. So the more elements I add, and I could do list.append, I could append whatever elements I wanted. I could append whatever elements I wanted to this list. And the more elements I add, it automatically assigns the next numeric index, right? So 22 here is at index 7. When I append foo, foo is going to have index 8. Bar is going to have index 9. Bass is going to have index 10. Etc. Right? So you'll notice when I print the list, all I see is the elements. But we can always count on each of these elements having an associated index based on its position. And that's done automatically. We don't need to do anything to generate that or make sure that's going to work properly. That's just going to work properly. So the question now is, how do we utilize that? So the way I can access an element at a specific number index is I could say the name of the list, the identifier for the list, which in this case is LST. So this will be list, and then behind it, or on the right of it, I'll put square brackets with no space. You actually can put the space, but it's not conventional. You'll want to put the name of the object, the identifier name of the object, the variable name, and then square brackets, and we'll index into, let's say, 3. So getting the element at index 3 is going to be 0, 1, 2. That'll be 22. 22 is at index 3. Right? So if I do index 4, that's going to be 33 here. Index 0, it'll be 55. Cool. So if I did this, oh, I accidentally ran it. I was going to ask you guys. Okay, so if I print the type of this, right, it's important to know that when I index into a given position, that's an expression that expresses the value at that position, right? So index 10 is Bass here, memory serves, BS. So that evaluates to that string at that location. So this is an expression that expresses the element at that index. Okay, so we've kind of seen a few indices. This syntax kind of has another name. We usually call this subscripting. This is from, if you can think of, if you're familiar with mathematical notation where we have like a sub and then some number, right? A sub 1 or a sub I or a sub k or something. That's the same thing being expressed here, right? So if you're familiar with that subscripting notation in math, this is meant to be an analogy to that. So the proper way of talking about this is we'll say list sub 3 would be that 22 there. Some mathematical notation will use an indexing system that starts at 1, where 1 is the first element in the collection. And some mathematical notation will use an indexing system that starts at 0. So given the context in a given mathematical expression, we're left to glean, the position being expressed in a given array in math. In Python, we always have to assume 0-based indexing when we're subscripting. What that means is we always have to assume that the first element is 0. There's never a case where this 55 is at index 1 in this particular list. It's always at index 0. So it's kind of funny, if I say hand me the fifth element in here. The fifth element is 1, 2, 3, 4, 5. That's at index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So that means when you're asking for an element at a given index, you have to kind of remember to adjust. What I would suggest is don't be afraid to run and print your code and make sure that you're getting the right element. Make your best guess and then calibrate that in. That's fine. Okay, cool. So that's an example of indexing. We're a little past halfway, so I want to take an opportunity to take a break here. Let's reconvene. Let's just reconvene at 15 after the hour. All right. Oh. Well, let's get back into things. Hopefully everybody had a good break. Okay. Okay, so we covered, basically I'm just trying to get us through this initial statement about lists, right? But they're a collection of arbitrary objects. They are ordered. This has to do with indexing. They are mutable. That's the part about appending. We basically covered each of these ideas. Somebody was asking about range and using range to associate the indices with a list. So yeah, so there's two functions that are really useful for lists. And I want to make a clear distinction, between a function and a method, right? A method has this sort of list dot or object dot method name syntax, but a method really is similar to a function. But I'll talk about a couple proper functions as well. Okay. So, range and len. These are two really good functions to know for lists, right? So, quick note, when I talk about, when I did the overview and I said, each of these three are going to be kind of about learning kind of how they fit in and, like the paradigm of like, how do I use this? Why do I use this? And then learning kind of the syntax of like, okay, what are the details of like typing this out correctly so that the interpreter can make sense of it. And then I said, most of your time will be spent in understanding data types. And this is actually a good example of what I'm talking about. We're about to pick up, for lists, we're building vocabulary. We're building a vocabulary of things we can do with list, right? So with any language, like you can, and I mean this for natural languages too, you can learn kind of the systems of grammar and logic and ways of thinking in that language, and that takes some practice. But where the time is a lot of times is in building vocabulary, which requires kind of memorizing how different things interact and memorizing the specific words and how they work together. So so I think of this as vocabulary building. This is the vocabulary building part. Now, fortunately, I mean, there is, I would say, I would frame this as like there is memorization involved. Like you kind of have to remember what tools you have at your disposal. But we'll kind of get into some things that, if I'll show you how to kind of get Python to at times help you if you don't remember something exactly. There's internal documentation that can kind of help remind you of what's available. So it's a little easier. Okay, so we're building some vocabulary with lists. We're going to pick up len. We're going to pick up range. We talked about let's do another category for methods. Append, dot append. Oops. Oh, I'm like, this is not, this is a different document. I hit the wrong key. So dot append as well. So we've picked up 3 sort of vocab for list, 3 vocabulary words for list. So a method and 2 functions here, and I could even add other operations. I could add, indexing slash subscripting, right? That would be something you'd want to memorize, that this exists and kind of how to work that. We'll probably talk about slicing, and that's related to that as well. Okay. So len and range, and we could do this for append too, but remember, I've been talking about this IPO thing, input process output. So let's do that for each len and range. So len is not limited to lists. It's a tool that can be applied to a number of different types. We can actually use it with strings as well. It's the other type that we've talked about that we can use len with. So let's do IPO for len. Input something that, and let's be clear, some type that has a length. Process we don't care about. Output is an int representing the length of the input argument. Cool. Let's read the Python documentation, the internal documentation. I'm going to start a Python terminal or a Python shell, Python 3, and then I'm going to use a really useful function. You can do this in your Replit shell as well. You can say help, and then you can pass in some function. Maybe you don't remember how len works. You can get the help docs on len. It takes a little practice getting used to the way the internal documentation in Python is written. Basically, this tells me len is a function. It takes in an object. You can ignore what the slash is for now. We won't talk about that. If you see the slash in there, you can just kind of set it aside. And this says, so it takes in an object and return the number of items in that container, in a container. And the container in this case is obj, what it's calling obj. And then to exit the help docs, I just hit Q, the Q key for quit. And then to exit my terminal here, I can say exit like that. Okay. So that just gives me the number of elements from the input, right? So if I called len on this at this state, right, I'd get 8 elements. So that has a length of 8. Notice though, its maximum index, its highest index is 7. So the highest index is always 1 less than the length. Okay. So that's for len, and then let's do another IPO for range. So we'll say, oops. Input. So range actually takes in 1, 2, or 3 arguments. It can take in any of those. It can't take in 0, and it can't take in more than 3. So if it takes in 1, it's going to be the stop, and it will generate a range from 0 to stop. And you saw that when I did range 10, and I cast it as a list, it generated a range from 0 to 10. Now that's great if I want to start my range at 0. If you notice too, you know, the range actually, so this includes 10 elements, but range 10 gives me elements 0 through 9, right? So the stop is not included. So when I do range 10, the highest element that it gives me is 9, not 10. So that stopping number is not included. So the stop is exclusive. So we'll say, so one argument is, oops, dang it, I keep doing that. Apologies. We'll say stop exclusive. Let's do that. Stop, which is exclusive. If it takes in 2 arguments, it takes in start, then stop. So start is inclusive. So the starting index is included. So this will generate a range from start to stop. And I'll give an example of this. If I wanted to print, if I wanted a range, and I wanted my range to include the numbers, let's say 15 through 25, I'd say print list. I'll cast it as a list just to make it clear which elements it's going to include. Let's just say 15 through 20. So I'll say range 15 because I want my range to start at 15 and I want to go up to 20, but my upper bound is excluded, so I'll have to add 1 to it. Of course, 20 plus 1 is just 21. So 15, 16, 17, 18, 19, 20. So that's range 15 to 20. So it's a little funky because you have to remember to add 1 to your upper bound. It's something that you'll get used to. So if I take 3 arguments, start, stop, and then step. So the step is the interval at which it includes numbers, right? So a step, so we could say generate a range from start to stop in steps of step. Now let's do this. Steps of step, like that. So if I wanted to do, let's say I wanted to count by 3s. So I could count in steps of 3 from 15 to, let's say, 30. Right, so I get 15, and I don't get 16 and 17, so I go 15, 16, 17, 18, and I add in 18. That's part of my range. Then 19, 20, 21. So next number is 21. Then 22, 23, 24, 25, 26, 27, then 30. Right, so this is how I could count by 3s. If I wanted to do range 0, from range 0 to in some step, I have to pass in all 3 arguments like that. Cool. So that's for the input, and then each of these is sort of a bit of a, I'm just going to call these the output here, right? We'll just do that. Generates a range from 0 to stop. Generates a range from start to stop. Generates a range from start to stop in steps of step. Okay, cool. So you can look, you know, the way I'm kind of laying this out is just whatever kind of way of notating this that's going to make sense. It doesn't have to follow a consistent form, but that IPO structure is just like, these are things that I may want to note. Is the input and the output, most importantly, and sometimes the process. Okay, so that kind of just, you know, goes over how range works and kind of how its inputs work. So let's look at it how let's look at how we can use it to get the indices of a list. So we can use it in conjunction with len, right? So let's say I have my list. I'll just take this one. So this list has length 8. Now, if I want to generate a range, let's say I want to generate a list of the indices for, let's call this num list. And I want to generate an index list. Yeah. IDX is a common short name for just a common abbreviation for index. So we'll call this IDX list. So I'll leave it to you. How do I generate? Well, big hint here, we're going to use range and len together. Range and len and the list function together, actually, to generate IDX list. So there's the prompt. So what would I do? How would I use those together to generate the IDX list? And I'll put a couple minutes on the clock for this. So your result, by the way, should look like this. It should print out 0, 1, oops, 2, 3, 4, 5, 6, 7, like this. And you're not allowed to just assign it to a list like that, because we already know that would work. Cool. All right, we'll leave that there. Go ahead and get in your answer. Right, so we can use, I want the indices of numList. Right, so in order to do that, I can do the len, and I can pass the len, which gives me an integer. Now range gives me a range equal to that integer. So starting from 0, which is, I know I want to start at 0 because my first index is 0, and I want to go up to but not including the length, right? Because my maximum index is 1 less than the length. Well, remember the IPO for our range? If I pass in one argument, stop is exclusive. And I apologize because I think maybe I didn't explain that well enough. The stop is always excluded, right? So range 0 to 10 gives me elements 0 through 9. Range 5 to 10 gives me elements 5 through 9. So let's see. If I pass in one argument, that's the length is 1 more than the largest index. It goes up to, but not including that last number. So this actually it reads as range 0 through 8, which generates numbers 0 through 7. That happens to be my indices. So when you're reconstructing the indices of a list, if you ever want the indices of your list, you can do range, len, list, right? And that'll give you the range. And I did want to cast this as a list like this. I'm going to put plenty of extra spaces in there because that's what I like to do. There we go. List containing the indices of numList. Okay. List membership. So we're getting into it. This is this has to do with. So here's an interesting one. We're kind of going to cross a little bit of a vocabulary boundary, right? So we're going to talk about in, which is a keyword, right? And in kind of, there's a number of places where this keyword shows up in various contexts, and it's kind of overloaded, so it can do some different things. But I'm going to show you one context in which it's used as an operator. We can check if some element is in list, and that's called a check for membership. And it gives me back a Boolean. So part of understanding Booleans, right, we have a lot of Boolean operators, you know, the equal, not equal, less than, greater than, less than, equal, greater than, equal, and then we have our logicals, which are not, and or, and then we have in. There's others, but those are the ones we've covered so far. So in is going to evaluate true or false as to whether something is a member of this list or not, right? So let's just print this off. Let's see if potato is in num list. So we'll put 5 minutes on the clock for this one. Go ahead and tell me true or false is potato in num list. I'm not really going to put 5 minutes on the clock. I just wanted to mess with you. Right. Potato is not, yeah. Okay, good. Potato is not in num list, right? This statement is obviously false. So as silly as it is, it's a valid Python statement. I'm checking this string potato and seeing if it's a member of num list. Of course, if I add potato in to num list, then it's going to be true. course, numList is no longer a good name for it because it's got a potato in it. So let's check for numbers. 97 is not a member of the list. 99 is a member of the list, right? So we can check for membership. And this is a really useful thing to do. You have some list, it's been built at runtime. You don't know what's in it, so you want to know, hey, is this object, is that a member? Is this element a member of that list? True or false? So you can use this in conditions. Condition is any expression that evaluates to true or false. We can use that to gate conditions, and we often will use syntax like that. Slicing. So we talked about indexing, and there's something about indexing that I forgot to mention. Oops. Okay. There's something about indexing that I forgot to mention. What happens, so we know we've got 8 elements in this list. What happens if I do numList and then I ask for a number that's outside of that limit of indices, right? I'm going to get an error. This is going to say list, list out of, this is an index error. It says list index out of range. So I have to, when I'm getting an index, I have to make sure that that index is inside the list. Oddly enough, I can ask for negative values. Now we can't do a -0. That's a nonsense number. That's not a real number in Python. But we can do a -1. So -1, if I ask for a negative number, when I'm using 0 and above, when I'm starting at 0 and going up, I'm counting from the left to the right. A lot of times it's really useful to be able to index into a list from the right to the left. So I can use negative numbers. So if I do -1, I'm going to get this 22 here. Oops. I was like, wait, what? I'm still doing that other one. So that's going to give me 22. -2, that's going to give me 55. So I'm counting from the right to the left. So 22, 55. Next one is 99, etc. So I can go up to -8. That's going to give me this number here, 55. So if I go to -9, then I've gone out of range in the other direction. And excuse me, let's fix this. So -8, or excuse me, +8 is the first number that gives me an index error. And we could do this. We'll do 7. 7's okay. And then -8. Oops. -8 is also okay. Oops. Right? But these middle ones are going to give me index errors. And that'll stop our code from executing. So 7's all right, but this gives me an index error. We'll comment that out. This gives me an index error. We'll comment that out. And these are the limits of this list. So this is -8 is the same as index 0 in this case. But it can be, like I said, there are times when it's really useful. Like, you don't know how long the list is, but you need like the third to last element. And that you might have a list that's like 10 elements long or 1,000 elements long. And you don't want to like reconstruct, well, how do I determine that? From the left-hand side, you can just say, okay, I'll subscript in using a negative number from right to left. So using negative indices can be really useful for that. So slicing. So slicing looks kind of visually similar.
we use sort of a similar looking syntax to indexing, and it's definitely a related idea. But when I index into a list, when I subscript into a list, the line in which I do the subscript, right, that expression expresses the value at that index. Let's see. Okay, sorry, we have a question here. Somebody's asking, so -1 would be 55. -1 would be 22. So if -1 were 55, then 22 would have to be -0. So it's kind of weird, right? Like when you count from left to right, you start at 0. When you count from right to left, you start at -1. So -1 is index -1 is 22 there. Okay, so yeah, so this, when we're indexing, list sub index expresses the element at that index. It expresses that value. So this expresses actually the 22 right here, right? This expresses 44. So this is the value 44. This is the same as writing 44. This evaluates to 44, and I can prove that. Well, you know, if I subtract 2 from it, it better equal 42, right? So that's going to give me 42. Okay, so that's the number 44. So slicing, we'll call this slicing. So slicing always evaluates to a list, okay? Slicing always evaluates to a list, and it's a way of getting some subsection of this list, right? So let's say I want to do a slice, and I want my slice to represent this sublist from 55. Let's just say from 55. Let's say to 33. 55 to 33. Okay. So 55 is at index 0. 33 is at index 1, 2, 3, 4. So 0 to index 4. So remember range. Take a note on range. Take start. Stop. This will become clear why I'm doing this. Step. Okay. Start, stop, and step. And there's a similar pattern with slicing. So I want my slice to represent this. I know I want it to give me this for this list. And the way I'm going to slice this list is, we'll do it like this. I'm going to put a colon in the square brackets here. Okay. And this colon tells Python that I'm doing a slice, right? And then this colon also acts as, you could think about it as a partition, right? So on the left of the partition is going to be, I can put in a number, and that number is going to be my starting number. And on the right of the partition is going to be my stop. And just like with range, start is included and stop is excluded. So I want to go from 0, so I'll say 0 because that's included, to 1, 2, 3, 4. So if I do 4, right, that's going to give me 55 through 22, right? So I have to add 1. So even though I wanted, this is kind of a funny thing, right? Because if we count to 33 here, 1, 2, 3, 4, 5, right? Really, I have to put 4 plus 1, which is 5, of course. And that'll get me to 33. So the stop is excluded just like in a range. Now, I also have the opportunity, so notice this gives me this sublist, right? I also have the opportunity to specify a step, right? Let's say I just want every other number. So every other number from 55 to 33. You get 55, 77, and 33. course, I could change this to any other number. So if I wanted to do a step portion, I would put in a second colon here, and then it creates these. The way I think about it is these 3 partitions, right? These 3 sort of empty spaces. So this will work with, if you do 1 colon, the 2 spaces represent, the 2 sides of the partition represent the start and the stop. If you do 2 colons, you have start on the left, stop in the middle, and step on the right. Same order that they would show up in with a range. So it's typical that you'll see, most slices will be some contiguous subset of the list. Contiguous meaning it's the numbers in order, so they don't use a slice, or excuse me, they don't use a step. They won't take in a step. But basically, you could think about the step being, if no step is specified, it's going to assume a step of 1, of positive 1, right? What I prefer to do is to always put in both colons. I just think it kind of reads, I don't know, it's an aesthetic choice that I always do. So you always see my slices, even if I don't need the step, I'll just always put in both colons. But it's more common that you'll see a single colon. So my habit is to do both. And if you're starting out with this, I remember this being kind of an oddball, kind of quirk of lists that was a little weird to pick up, but I think it can be helpful to just put in both colons. That way you always have the whole thing kind of represented, and you can remember, okay, on the left is my start, in the middle is my stop, and then on the right is my step. So what happens if you don't specify one of these? So there's an assumption made about each one of these, right? So if I don't provide a step, it's going to assume a step of 1. If I don't provide a stop, it's going to assume that I wanted to stop all the way at the end. In other words, len numList, which will be all the way at the end. So if I don't provide a start, it's going to assume I wanted to start at the beginning. So it's actually totally valid to do a slice like this. I didn't specify a start, so it starts at the beginning. I didn't specify a stop, so it stops at the end. And I didn't specify a step, so it gives me every element. So what this actually does is return a different list. So I've duplicated the list in my program's memory. I've asked for a different list, and it just happens to have the same values. So I've copied it. And we'll talk about list copying at some point as well. We've got this little section on nested lists here. I'm going to kind of skip it for now because you can read through that if you want, but honestly, I kind of feel like we'll get into this later, and it feels a bit dense. Cool. We're running short on time. Don't have time for the breakouts. I'm gonna kind of reconstruct a few of the breakouts that we missed for next class, and we'll kind of have a big breakout session. So, all right. So this is a note on mutability and copying. So we talked about mutability. This way of slicing will give me a copy, and let's actually, we've got 5 minutes left, so let's actually look at what that is. Let's look at another function, the ID function. ID takes in any object and outputs the internal ID of that object, right? So this is the it's like a serial number. So each point of data gets like essentially a serial number associated with it. while the program is executing. You can think about the ID as sort of a pen number or an identifier number, a serial number, if you will. So let's look at this. If I say numList, let's print the ID. Let's actually do this. I'll say list equals an empty list, and we'll print the ID of list. And let's print its value as well, list, like this. And then I'll say list dot append hello. We'll append the string hello. So the question is, remember, append changes the value. So the question is, does the identity change? If the identity changes, it's a different object. If it stays the same, it's that same object, right? So the analogy would be, if I had a car and I got the car repainted, if I took my car in to get it repainted, I have a black car, if I wanted it to be repainted red, would you say that I got a different car, or would it be the same car where the value of its color was changed from black to red? So I would mutate the paint job, right? Mutate the paint from black to red. So, oops. Which behavior can we expect? Will the ID stay the same when I change the value, or will it be different? Go ahead and put that in Slack. Real quick here. This is another kind of test of intuition. Same or different? ID stays the same. Cool, yeah. So this will stay the same, right? Same ID. It's kind of a big number, but it's the same. If I had done list equals list with hello, like this, you can see this gives me a different object, right? So this is like, I have a black car, I want a red car, so I sell my car and get an identical car, except the only difference is that it's red, right? So this is getting a whole different object and loading that into memory. Often it can be advantageous, since we have the capacity to alter the value of a list. A lot of times you want to make sure, you have a list, you don't want to mess with its value, but you need to do some mutable operation to it, right? So what you might do is make a copy of that list and then mutate it, right? So if I had hello, we'll start this list with hello in it, like this. And let's say I want to do like I want to do like list dot append world, like this, right? But let's say I didn't want to alter my original. I could say other list equals list dot copy. I could also use the slice to copy, just a full slice. Sometimes this is called a full slice. It has the same effect as using dot copy. I recommend you use the dot copy method because just get in the habit of this, because other data types will use the dot copy method for the same reason and it works the same. So just use dot copy. But so I could do other list, and then I could say other list equals list dot copy. So other list is now a unique list. So I could print the identity or the ID of both of these, and you can see now. Oops. Now if I print the my original list, that didn't change it. So I appended to the copy. The copy had the same data in it, but it didn't change my original list. So copying can be a useful thing to make sure that you're only causing changes where you want them to be. You do make a bit of a memory sacrifice because you, however big that list is, you take, you have one version of it in memory and then you copy it, so you literally duplicate all that information into the copy. So if it were some huge object, that might be a significant memory footprint. If it had 1 million elements in it, which it could, but that might be a memory intensive operation. But yeah, for most cases, in a lot of cases, okay, well, this is going to be small enough that that memory footprint isn't going to be huge. So copying can be very useful. So anyways, we're a little over time. Sorry about that. I'll wrap up here. I think we got through a lot today. We'll do a quick recap. So we talked about lists. The big takeaway with this, it's a collection of elements. We can mix and match any type of element. Each element automatically has an index assigned to it. The first index starts at 0 and counts up. From there, we can index with a positive or negative number within the boundaries of the limitations of that list. And we can access an index with square brackets. If we want some sub list, we can use slicing, and that works similarly to indexing, except we add in the colons, and that follows that start, stop, step pattern as well. We have len to get the total number of elements in a list. We have range to generate essentially the indices for a list. We can also use range to just generate a list of numbers. That doesn't necessarily have to be matching the indices of a certain list. So if you just need to represent all the numbers between some lower and upper bound, you can use range for that as well. Cool. So those will be the takeaways, and yeah, we'll wrap up there. Let me stop the recording and we'll open up for questions.